What's up guys, and welcome to this video. We're going to go over question 3 of the 2018 final exam. Yeah, let's get straight into it. Okay, so question 3. Question 3.1, the velocity versus time graph shows the motion of two different objects sliding in a straight line across a horizontal surface. Okay, so I'm going to take a look at this graph quickly and let's see. Okay, so this velocity here is a low velocity and it ends on a high velocity. Okay, so this k graph is actually speeding up. Okay, if we look at okay, so for example, the reason why I'm saying we're speeding up is if we actually give it values. Let's say this is obviously something, let's say it's 2 and k ends up higher, so we can say that it ends up at 7. Okay, but if we look at the opposite L graph, so let's say this is -7 and it would end up, let's say, at -2. Okay, so this graph for L is actually slowing down. Okay, so the reason why I say it's slowing down is it's going from -7, which let's say is just the minus just indicates a direction, so it's going from 7 meters per second to 2 meters per second. So it's going from a high velocity to a low velocity, so it's slowing down, whereas the k graph is going from a low velocity to a high velocity, so it is speeding up. Okay, and just understanding this will help us answer the question. Okay, so question 3.1.1. Could friction be the cause of the change in velocity for k? Okay, so what does friction do? Friction opposes the so friction is a force that opposes the motion of an object. So if it opposes it speeding up, friction would slow it down. So the answer is no. Okay, so friction can't be the cause because the velocity is increasing. Velocity is increasing, and friction opposes the motion of an object, or we can even say that friction would try to slow down the object. Okay, whereas for k, the velocity is increasing, it is speeding up, so it cannot be due to friction. But if we look at the next, okay, and we get 3 marks for that, question 3.1.2, could friction be the cause of the change in velocity for object L? So in this case, the object is slowing down, so we can say yes, it is, and we get ourselves 1 mark there. Okay, yeah, and let's move on. So a hailstone of mass 0.7 kilograms from rest at the top of a storm cloud. Okay, so it falls from the top of a storm cloud. The average acceleration of the hailstone while falling through is that. The hailstone reaches the ground with the speed of that. Okay, so we start off with a definition. So define acceleration, 3.2.1. Okay, acceleration is the rate of change of velocity. Okay, and we get 2 marks for our definition. Okay, question 3.2.2, calculate the distance the hailstone traveled from the top of the storm cloud to the ground. Okay, so we've been given the average acceleration, so this problem we can say is a constant acceleration problem. Okay, and with constant acceleration problems we can use UVAT. Okay, so let's UVATS. Okay, so initially we know it's at rest, so U is 0, final is 34. Okay, and I'm going to be defining downwards direction as being positive because the motion is mostly downwards. The acceleration is given to us as 0.21 meters per second squared. The time is unknown and S is what we're looking for. Okay, so we can use the equation V squared equals U squared plus 2AS. Okay, V squared is 34 squared is equal to 0 squared plus 2 times 0.21 times S. The only unknown is S, so we can solve for S, and S is 2,752.37 meters. Okay, so we get the distance traveled by the hailstone. Okay, so there we go. Question 3. Question 3.2.3. So falling objects normally have an acceleration of 9.8 meters per second. Explain why the acceleration of the hailstorm is much less. Okay, so this is true. It usually would be 9.8 downwards, but obviously if we draw a free body diagram, let's say we have Fg, which would be weight. So there's obviously a upwards force, cancelling some of that weight, which would probably be F drag, or drag. So the reason for this, so it says explain why the acceleration is much less. We can say there are upward forces acting on the hailstone. That would be, so we can say upwards forces, let's put in there drag, or air resistance, or friction, or something like that, acting, not only weight. Okay, and that would be your reason, and we'd get ourselves 2 marks there. Okay, cool stuff. Okay, so let's move on to question 3.2.4. Okay, on reaching the ground, the hailstone pierces 12 centimeters, so that's 12 times 10 to the minus 2 meters, into the ground before coming to a rest. Okay. Okay, so if you wanted this in meters, 0.12 meters. Okay, so it says calculate the acceleration of the hailstone while piercing the ground. Okay, so while piercing the ground, we want to figure out the acceleration. Okay, so we can use UVATS once again, UVATS. Okay, so we know the initial velocity, or we know, the initial velocity we know as being in the question as 34 as it reaches the ground. So it's 34 meters per second. The final is when it comes to rest. So it's 0. The acceleration is the unknown, which we want to calculate. The time is also unknown, and S is given to us as being 0.12 meters. Okay, so let's just define the direction to make sure we have everything correct. So we're going to take downwards as being positive, and this goes 12 centimeters into the ground, so all the directions are correct. And then we can use the equation we can use the equation v squared equals u squared plus 2as. V is 0 squared equals u is 34 squared plus 2 times 0.12 times s. The only unknown here is s. Oh, sorry, that's not right. It's 2 times a times 0.12. So the only unknown here is a. And solving for a, we get a is equal to minus 4816.67 meters per second squared. What does this minus indicate? It just means it's in the opposite direction. So we can say the acceleration is equal to 4816.67 meters per second squared upwards. Okay, and that would be the final answer there. Cool stuff, and we get ourselves 4 marks. Okay, last question, 3.2.5. It says calculate the magnitude of the force of the ground exerted on the hailstone. Okay, so we want the force of the ground. Okay, so let's just think about this quickly. So we have the forces acting would be Fg, or weight. We would have force of the ground, F ground. Okay, I'm actually going to say this is weight. Okay, so what we can do is we can use the following. We can say that F net is equal to M. F net is equal to M times A, and we're going to take downwards as being positive. So downwards as being positive. Yeah, okay, so what are the forces acting downwards? So the net forces, so F net is equal to MA. F net is the sum of all the forces, so it's going to be weight, which is downwards, which would be positive, minus F of the ground. Okay, is equal to the mass times the acceleration. Okay, so we know what the weight would be. We know the mass was 0.7 times 9,81 minus F of the ground is equal to the mass, which is 0.7 once again, times the acceleration. Okay, but remember the acceleration was upwards, so it's going to be minus minus 4816,67. Okay, so the only unknown here is that value right there. So we get that the F ground is going to be equal to, okay, let's just rearrange this. So it's going to be 0.7 4816,67 plus 9,81, just rearranging everything, and that comes out as being 3,378,53 newtons. Okay, and it asks for the magnitude, so we don't care about the direction. But if we did, this direction would be correct, so it would be upwards. If we did care about the magnitude, I mean the direction. Okay, and we get 5 marks for that. Yeah, and that's the end of the question. And in the next question, we will be going over question 4. In the next video rather. Okay, thanks for watching guys, I hope you found it useful.